Oh, good. Good afternoon, everyone. This is Steve Adler from IBM, and this is the third in our series of XMILE webinars. And today we'll be hearing from Billy Schoenberg and Gary Baxter, who will talk to us about XMILE's display and interface, gaining insights from models using this new markup language for system dynamics. Who would like to begin the webinar?
Great, thanks, Steve. This is Gary. I'm going to go ahead and start. And today, what I'd like to do is introduce some display and interface objects in two of the popular modeling tools, and then highlight some significant benefits to modelers of having a standard set of display and interface capabilities. So when we're talking about display objects, what we're talking about are all the visual objects representing model equations in a stock and flow diagram. And these are what you normally consider the building blocks of a stock and flow diagram: stocks, flows, auxiliaries, and connectors. But we also have another set of visual objects such as groups, ghosts, aliases, etc. And Billy's going to be talking a little bit more about those in a few minutes. So I'm going to switch into my Vensim software here, and here you see a stock flow diagram of Jay Forrest's corporate growth model. It's a very basic model, simple Model 3 stocks, but is capable of producing some very interesting dynamic behavior. And you see, but it fits nicely on one page, and it's basically stocks, flows, auxiliaries, and connectors. So in this application, Vensim, we do have quite a bit of flexibility as to which attributes I can control over these visual objects. If I select the backlog stock here, and down at the bottom of the screen you can see that there's an option to perhaps change the font. I can change the size, make it a little bigger. A whole series of options here. Say I want to take the title out of the stock, I can do that. So there's a very interesting set of attributes here available for my customization as a modeler. Now, if I switch over to iThink, you can see it's a very similar model, but the key distinction here, it's not the same model, right? It's a different file, a different file format, and although it looks the same, we do have different options available to us as modelers to customize this display. So if I want to take this label and move it outside, it's drag and drop. If I want to change the color, I have some options here. And let's say I want to change the font. It appears that I have to go to Model Preferences and change the font for all the objects. And I'm really not trying to point out the benefit of one application or another. All I'm trying to display here is that there's a different set of attributes available to us as modelers. So there's nothing unique about how they're implemented from my point of view. Maybe the vendor thinks differently, but as a modeler, I don't. They look the same and they feel the same to me. But yet I'm presented with a non-standard set of attributes that I can customize. So moving on to interface objects, these are all the visual objects that allow the modeler or customer to interact with the model. And these are objects such as buttons, graphs, and input sliders. And again, there's a whole bunch of these other objects that Billy's going to get into in a few minutes. So I'm going to switch back into the software and take a look at iThink. And here I'm going to go to the interface tab or layer. And you see I've built a fairly simple interface here with an input slider. It allows me to adjust the initial value of an auxiliary called Salesforce Adjustment Time. I've got a push button that runs the model, and I've got this time series graph that plots the value of the backlog stock over time. And you can see that there are two lines here. So this is a comparative graph. And so I can play with this auxiliary value here, run multiple versions of the simulation, and see the results here very quickly. It's very, very powerful, very simple, but very powerful. And so here, I think presents you with some attributes here to control the visual display of that graph. Over in Vensim, I have created a new view, very cleverly labeled interface, and an attempt to create the same type of capability here. I was able to find, be able to produce a Salesforce adjustment time interface slider. The version of software I have on my machine here does not let me create any push buttons to run the model. But I was able to produce a very similar graph here of backlog. And in, sorry, did something here. So in Vensim, there's a different set of capabilities for the graph, which I wasn't able to show you right there because of my screen. But here we have, again, a very similar situation. Nothing unique here. They look basically the same, and they feel the same. But again, I'm presented with a non-standard set of attributes that I can customize. So this current situation, you're probably going to hear it again for the third time, very similar, but no standard set of attributes that they share. I have two separate models in two separate file formats. And when I start off on a modeling project, I need to pick a package that I'm going to use to create the model. And then I often have to live with that package throughout the duration of the project. Now I know there are conversion utilities that allow you to convert one file format to another, but the end result of that is still two models. And as the project evolves, I don't want to be maintaining two models. So in this scenario, you're limited to that package's features and functionality. So imagine you fast forward here into the near future where all the vendors have adopted the XMILE standard, and we have a common file format and a basic core set of capabilities. So this makes for a truly portable model. And now all the features and functionality of all the packages are now available to me. So imagine creating a model in Vensim, saving in an XMILE file format, reading that same file in iThink, and then taking advantage of, say, iThink's storytelling features, capabilities. And conversely, how about creating the model in iThink, saving in an XMILE file format, loading it into Vensim, and taking advantage of their synthesis capabilities. So you can see that the possibilities are significant. So this doesn't necessarily result in better models, right? But it results in an opportunity for me to produce better models. Whether I do that or not is still up to the modeler. But this opportunity here is significant and definitely worth working towards. And also, it allows for easy consumption of my models by other applications. So, for example, Folio, or some application that hasn't even been thought of yet or developed. So, in order to get to this wonderful place in the future here, we have to have the standard adopted by all the vendors. So, here's what I'm asking of all you modelers. Just do your part here, and ask your vendors when they plan to adopt XMILE. And note, it's not if they plan to adopt XMILE, but when. And when I ask that question, this is what I'm looking for. I'm looking for something that says they're committed to implementing the standard in a very short order, right after its adoption. So now I'm going to turn it over to Billy Schoenberg of IC Systems.
Hi, so I'm Billy Schoenberg from IC Systems, and thank you, Gary, for giving us an introduction to the problem and the current state of affairs within the system dynamics community. And so what I want to do with you guys today is kind of talk to you about the solution to this problem and what the XMILE standard has to offer. So what I'll do is, for those of you who haven't heard about the standard, I'll just give you a quick introduction so that you can come up to speed. But then afterwards, what we're going to do is we're going to get involved in technical aspects of the specification, and we're going to go over kind of how all of this works. How do we make this happen? So let's go ahead and let's talk about what the XMILE standard is. So like Gary has been saying, it's an open standard, and it's a file format for sysdynamics models. It's a way for all of the vendors within the community to communicate models with each other, as well as, like Gary was saying, for software packages that don't even exist yet to be written, and to be able to leverage the large existing body of models which already exist. It's been developed by the OASIS Technical Committee, of which Gary and I are members, which was formed in June of 2013, composed of vendors as well as individual practitioners. But don't think that this was just something that sprung out of thin air in June of 2013. This is something that the community has been working towards for more than a decade. And this particular effort has been really based on a draft standard which was put together by Karim Chichakly in 2007. And what we're hoping to do is have a release draft in July of 2014. We're very quickly nearing a vote on the draft within the technical committee, with a final release in the fall of 2014. So let's get into some of that nitty-gritty that I was talking about. Let me answer the how question of how the XMILE spec works in translating stock and flow diagrams. So to really understand the meat of the problem, you have to understand the XMILE view. A view is just an abstract container for XMILE display objects. So like Gary was saying, display objects are stocks, are flows, are auxiliaries, things like that. So the view is a bucket which contains items, the items being the display objects. Now within XMILE we have different types of views, and these types can be specified optionally. But thinking about it, we have two main types of views. We have our stock and flow views, where our model structure is shown, and we have our interface views. And our interface views are where we build our interactive learning environments. We also have views for pop-ups, or potentially vendors could have their own different kinds of views. And an important thing to note is that within views, only variables, the canonical definition for the display of a variable needs to show up within a stock and flow view. Views, they have sizing. They're rectangles. They've got a width and a height, which are stored as a double. So you'll see this notation that I use commonly, this angle bracket for describing the type of data that we're storing. A double is a double precision floating point number. Zoom is also stored as a double. So think about it. When you save a stock and flow diagram and you're looking at a particular section of that diagram, when you open the diagram again, you want to be looking at the same exact screen, which means we need to save the zoom as well as the scroll position. And finally, views can have background colors or background images, so that we can have items in the background which aren't necessarily interactable with the mouse, but provide context or an aesthetic view to that XMILE view. So here's just a simple graphic of what an XMILE view looks like. It's a 2D Cartesian coordinate space where the origin is in the upper left. X values increase to the right, Y values increase as you go down. So let's talk about some assumptions and some attributes of XMILE views. So all objects in a view, all stocks, flows, etc., they have to have a position. An X and a Y value as doubles, your Cartesian point. They also must have a size, a width and a height, stored as a double, or they have to have a shape. And a shape is defined using a tag. Now, there's a couple of rules for that shape tag, because we know what we don't want is for models to turn into this confusing mess. We like that stocks are always rectangles and that auxiliaries are typically circles, and so that anybody looking at a sysdynamics model, regardless of the software that it's in, can recognize that model. So to keep that property of models intact, what we've said is that stocks can't be represented using a circle, and that auxiliaries and flows cannot be represented using a rectangle, except for a certain rule, if they contain a macro or a function with an implicit stock. So think of a built-in function like delay. An auxiliary with that built-in function in it actually has an implicit stock within it. So then it is allowed to be represented using a rectangle. So the shape tag allows for the specification of arbitrary shapes for any display object as long as it follows the above two rules. So shapes have types. You know, the most basic type is a rectangle type. We also have a circle type. We also have this special type called name only, and that's what allows us to specify an auxiliary, for instance, by only referring to its name. There is no circle, there is no square, there's just the text, and the connector arrows point to and extend from the text. So rectangle shapes, they require a width and a height, and optionally a corner radius. So think of the IC Systems module, it's a rounded rectangle. Circle shapes, they require a radius, and name-only shape, it's a marker. So width and height can be included, but may not be respected by all vendors. And the width and height, if they are included, would affect word wrapping, of course. So let's now talk about how we reference variables within an XMILE view. So we have, variables, our equations, and how do we link those two separate portions of the XMILE file. So last week, Will was talking to you all about the variables tag. And within the variables tag, there was the stock tag, the flow tag, the aux tag. How do we link those, equation descriptions to the actual visual representation of them? So what we say is that for each tag that shows up within the variables tag, there is a corresponding tag within the view that is linked to that by using its name. So let me give you an example of that. So if you look here at this XMILE snippet, and this is, obviously a very bare bones snippet, it's not valid XMILE, but it's enough to show the point. Within the variable section of the file, we have a stock defined called myStock, and like I said, it's not fully defined, it doesn't have an equation or anything like that. But the way that we refer to that stock within a view, within a stock and flow diagram, is by referring to it by name. So we have stock, my name stock, which has a position and a size, refers to the variable stock. And that's how we make sure that we can link the pictures to the equations. And then as before, I was mentioning the canonical representation, and all that is fancy speak for the first encountered display object tag, like this, for a variable object. So what we're saying is that you can actually have multiple views for a single equation. So then what about objects that don't have names? So things like connectors or things like graphs and tables, how do we refer to them within a view? So like I just said, graphs, tables, sliders, buttons, they don't have a name. But for them, what we do is we refer to their unique identifier, their UID. It's a linearly increasing integer. It goes from 0 to int32 max, which is a special number for those of you who are technical. It's the highest number that can fit within a 32-bit integer. That UID linearly increases. It's not stable across I/O operations, so this isn't a universally unique UID. It's just a UID that is unique for that particular instance of the model. And this UID is unique per XMILE model. So what that means in practice is that if you have a model which embeds multiple modules within it, the UID will restart from 0 within each model tag. And essentially what UIDs do is they allow us to refer to objects that don't have a name. We just use the UID instead of their name. So let's talk now about ghosts or shadow variables and how they link to the concept of an XMILE alias. So an alias is a symbol representing a portal, kind of like a wormhole, to display of another XMILE model object in the same view. So think of a stock and flow diagram, which is getting kind of complicated. You have connectors all over the place crossing each other. What you can do is you can create an alias, or ghost in IC speak, shadow variable in Vensim speak, put it on the other side of the diagram, and you can have connectors that leave the alias, but you can't have connectors enter the alias. So alias is an example of an object that doesn't have a name. Therefore, it requires a UID. So here's a sample alias tag. It's got its UID so that we can refer to it. It's got its position, and it uses the of tag to describe what it's an alias of. So the alias tag also by default inherits properties from the object that it is of. So for a stock, it's going to show up as a rectangle with whatever size the stock is specified with, unless that size or shape has been overridden within the specific alias tag. So let's talk now about how we describe the visual relationships between variables. So we're very familiar with this, when we have, for instance, a connector. So we use the connector tag to describe the visual relationship between two equations. So a connector, just like you're used to seeing in BenSim or iThink or PowerSim or anything, is an arrow, and it only ever appears between two display objects. So this is how we describe a connector. The connector is a tag. It's got a UID because it has no name. It's got a position, which is the position of the takeoff point of the connector, as well as an angle, which is the angle in degrees of the takeoff point, where 0 is 3 o'clock and angles increase in a counterclockwise fashion. That way we can describe the shape of the connector. And connectors always go from something to something. And connectors can go from an alias, and that's how we use a UID, to any other XMILE display object, like a flow. The typical connector is an arc, but with XMILE, we can represent Bezier connectors with multiple points using the points tag. So inside of a connector, you can have a tag called points, and inside of the points tag, you can have individual points, which refer to positions, absolute positions within a view, to create a connector that looks like this one here in the bottom right-hand portion of the slide. So now let's talk about some commonly seen display object attributes. So what things does XMILE allow us to customize? It allows us to customize border widths, border colors, border styles, none or solid, font families like Arial, Tahoma, Courier New, font styles, normal or italic. We use an enumeration here so that we can add more font styles in the future, maybe oblique. And these are really borrowed heavily from CSS. As much as possible, we've tried to stick with the CSS standard. So we have font weight, normal and bold, text decoration, normal and underline. Again, all enumerations so that we can add to them. Text align, so how is the text aligned within its area, left, right, and center. Vertical text align, top, bottom, and center. Font color, which allows us to specify the color for any particular piece of text as an RGBA hex code or a predefined color. Text background, to describe the color on which the text is printed on top of. The font size, describing the size of the text. And padding, which describes the amount of space left around the edges of a display object. And again, all borrowed from CSS. Finally, we have a foreground color, so different display objects use this field differently, as well as a background color. And finally, we have a z-index, which specifies the stacking order for objects within a 2D plane. So because our views are two-dimensional, we need a way to specify what objects appear on top of other objects. And so for that, we use a z-index. So let's talk about how you can use these properties within XMILE's cascading style system. So styles, they refer to a group of XMILE objects. You can say, okay, let's take these objects and give them this set of attributes. That way, I only have to specify that set of attributes once. So here's a sample style tag. In this style tag, by default, we want everything to be blue with a font size of 10. But for stocks specifically, we want them to be bold, and we want them to override the blue color and be black. So the way the style system works is the closer, the more specific the style is, the closer it is to the display object, the higher precedence it has. So any style specified directly on a stock tag or an aux tag have the most precedence. Those specified by type have the next most precedence, so on and so forth. So in this little example style tag here, any related stock object would have a bold, black size 10 font. Any related flow object would have a normal weight, blue, size 12 font. So this is where we can put style tags. We can put them as the root of the XMILE tag, affecting all models within that particular file, as a child of the views tag, affecting all views within that views tag, or as a child of a view tag, affecting all display objects within that view. So now we've got all of the building blocks together for building a stock and flow diagram in XMILE. So take a look here at this stock and flow diagram here that I have at the bottom right-hand portion of the screen. What I'm going to do is I'm going to reveal to you all of the XML that's necessary to represent that diagram. So here we've got our model, which then has its group of variables, and this is what Will was talking about last week. So I just put ... rather than listing out all of the full properties. But we have our equations defined there. We then have our views tag, which defines all of the views that are going to appear in this model. And in this model, there's just a single view, and this view is styled. It's got, by default, an Arial font of size 9. That's blue with a blue font color. The view that we're about to make here is a stock and flow view. It's got a width, a height, and a zoom. Inside of that view, we then have display object tags for stock, which refer back to each one of the equations. So we have our stock named savings, which refers to our equation for savings. It's got a position and a size. Same thing with our flow. The flow introduces the points tag to represent the start and end position of the flow. And we have our auxiliary tag, which represents our aux, which represents the interest rate. We then represent the connectors using connector tags. And we represent the takeoff point using positions, and we go from and to, from and to. And finally, we end our model. So that's all of the bits and pieces that you need to represent a stock and flow diagram within XMILE. So now let's talk about interfaces and interactive learning environments. These build on the same principles that I've laid out before in how we represent stock and flow diagrams. So here I'm going to be a little bit more high level, a little bit more abstract. So let's talk about what kinds of interface objects exist within the XMILE specification. We've got stack containers. We've got input objects, so inputting data into the simulation, changing parameters. You can do that using a slider or a knob, switches or radio buttons, numeric inputs, list inputs, or graphical inputs. On the output side, this is how we show data to our model users. We've got numeric displays, lamps, gauges, graphs, and tables. And then finally, we have our objects that don't necessarily perform any data-related functions, but provide visual or aesthetic cues which help the learning, such as text boxes, graphics frames for images or video, as well as buttons, which allow us to perform a variety of actions. So let's talk about the first one of those objects, our stack containers. So things that go into a stack container, which is essentially a mini view, they're stacked views essentially, are tables and graphs. Like Gary was telling you, tables and graphs can show comparative results from multiple runs. So this would be an example of a stack container here. I've got a graph, which is in a container. It's got this arrow button. When I click that arrow button, a new graph appears directly on top. So here I've offset them so that you can see the fact that they're different. But within each of the applications, the views will appear one directly on top of the other. And so I can navigate through that stack container using, in this case, an arrow to go through and see the third graph. And so that's how stack containers work. Inside of stack containers can be tables and graphs. So this is how a stack container is represented within XMILE. We use a stack container tag, which has all of its associated position and sizing properties. I've left those out just to save space here. It adds the visible index, so by default, which view is visible. And this stack container here with 3 graphs would be represented using 3 graph tags inside of the stack container. So now let's talk about some input objects. They allow users to enter simulation parameters. And here's some examples. We have got a knob. We've got a slider. We've got switches. These are 2 different kinds of switches. And these are IC systems, representations of these objects. I could just as easily have cribbed multiples of these from Vensim or PowerSim. We've got the graphical input device, which when we press it, brings up a drawable line graph for us to change values within. And we've also got ourselves a list input device, which when we click the value, allows us to change the value of a variable within our simulation. And so here's an example for how we would write a slider to an XMILE file. So again, I've just abbreviated all of the properties that are required using the ... And we tie the entities for which these display objects or input objects control by using the entity tag. So we say this slider refers to, takes its value from, sets its value to the entity named input. And then we have this reset to tag, which allows us to change the value of the slider of the entity back to a particular value after a certain condition. So you can reset to after a time step, after a DT, after a simulation run. So let's talk about output objects now. These show simulation results both instantaneous and over time. So we've got numeric displays, lamps, and gauges. Those are our instantaneous devices. They show us point data for any point in time. And we've got tables and graphs, which are typically over time. Graphs, not necessarily all of them are over time. The one exception to that, of course, is bar charts. And so here's, some examples. We've got a table. It's got, a couple of columns, many rows with time. Up here is where our numeric display is, as well as our gauge. A lamp kind of looks like a traffic light, for instance. And so this is the tag that we would use to represent this table. Inside of each table, we have items. The items represent either the columns or the rows, depending upon whether the table is vertical or horizontal. Each column or row item has a type, whether it be time or whether it be a variable type. And within the rows or columns, we again have entities. And so that's how the table knows what variables are contained within it. So for this table here, we would have 4 items, the time type item, and then 3 items representing each one of the entities, stock 1, flow 1, and converter 1. Finally, let's talk a little bit about annotations. These are used for putting pictures, videos, static text, buttons, into simulations. These are all of our helper objects. Buttons can perform a wide variety of simulation-related actions. They can navigate between pages or between views. They can cause actions to happen, like running the simulation, pausing the simulation, stopping, restoring data. They can import or export data from within the simulation, out of the simulation, or vice versa. And they can also display for us information, whether it be text, images, or videos. So at this point, I'd like to stop talking and kind of turn the floor back over to Karim, who will help gather some of your questions, which hopefully Gary and I will be able to answer. And I just want to let you guys know that we've got more webinars coming up about XMILE and more discussions. On June 24th, we've got a panel discussion. And at the ISDC this year in Delft, there'll be a roundtable discussion and ballot on the draft version of the standard. Thank you very much. Let's open the floor up to some questions.
Billy, I just wanted to say I thought that was a fantastic explanation. I thought you did a great job. Billy and Gary, you both did a great job of really helping to demystify how XMILE works and illustrate how things we take for granted every day get written in XML. I thought it was just a great presentation.
Great. Hopefully had the same effect for all of our audience members.
Thank you, Billy. And I just want to point out the SMILE panel discussion is with members of the System Dynamics community to talk about XMILE and how it might impact their work. We have one question. Since views are optional, what should happen when a software package which requires diagrams such as iThink imports an XMILE model without a diagram? So it's really up to the vendor what they want to do. You should be able to open up a model and run it technically. So iThing should be able to open it. I don't know, it wouldn't be able to show anything for a diagram. You can also optionally have a picture of the diagram if you wanted to have that appear instead. The next question is, will rotated text be available?
So within this version of the specification, it's not explicitly set out. Could be done through a vendor-specific property. So it wouldn't necessarily apply to all display objects. It would particularly apply to the text box object. And at the moment, the text box object that's specified in the draft spec does not account for rotation.
Great, thank you. And how is storytelling handled?
So at the moment, storytelling is not a standard XMILE feature. Since at the moment, IC Systems is, I believe, the only implementer of it. I may be wrong, though. I think there may be other packages which do support subsets of it. And at the moment, it's implemented using vendor-specific tags. So it will still show up within the XMILE. So you still get all of the benefits of having a text-based format, all of the version control benefits, as well as potential for interoperability because it is displayed within an open format. But it's not formalized and standardized throughout this process just yet. We wanted to cut off a chunk of the most usable cross-product items so that we developed a spec that was as usable as we could make it without being so daunting that nobody would ever implement it.
So the question is, you probably know of Insight Maker, which is pretty neat too, and by the way, I'll just add it, does have storytelling also.
That was what I was trying to think of.
Is it compatible with XMILE and vice versa? And I can answer that because I've been in conversation with Scott about this, and it is not at present, but he is busy implementing import and export from XMILE. The next question is, are there XMILE challenges with the Stella Modeler for iPad implementation?
No, not at all. In fact, the Stella Modeler for iPad application actually uses the XMILE format that version 10 of iThing and Stella use. That's how they're able to communicate so effectively with each other. And as this standard gets formalized, we will then be upgrading each of our products to support this standard the second it gets formalized.
Yeah, that's an important point, actually. The standard has been evolving as this committee's been meeting over the past year, and so at any moment in time, any particular software is not going to be up to date with it because it's going to lag behind the changes that are made in the committee. The next question, which is more really about what Will went over on the simulation side, but if you want to take a shot at it, are math statements guided by any standards?
Yeah, so within the specification, there's, if you actually read it, chapters 2, 3, and 4 specifically really go over the language which is implicit within all of the equation tags. And it's a pretty structured language, which takes its root from, years and years and years ago, Dynamo. But has obviously been modernized, thought through a lot, and is really the most common set of language features across all of the software vendors.
Thank you. The next question is, does the run data get stored in the XMILE?
No, at the moment, run data is handled outside of the XMILE. I know at IC Systems we use a SQLite database to store per run information. I believe Vensim uses its VDF files, and I'm less familiar with PowerSim or any of the other tools. There are data tags for referring to run information within the XMILE file, but there isn't yet a common specification for simulation data.
Right. The intention is that simulation data is completely outside this. This is describing the model and how the simulation behaves, how it's displayed. The data is referenced outside in all cases, as Billy said. Are there plans to standardize the data file format?
I think we'll kind of take that as it comes up. So like we're saying, this is the first draft of the specification. It's been 10 years to get us to this point, where we finally gotten the vendors down at a table talking about how we can share information. So now that people are at the table and we'll look at how adoption of the standard happens, I could definitely see this being a major pain point in the future for all of our customers, speaking as a vendor, which I think would provide lots of incentive for us to eventually standardize. But as specified currently, the standard performs all of its duties without requiring the data to be standardized. Therefore, with the intent of keeping the implementation barrier as low as possible, we've left that out of the standard.
Thank you, Billy. This is a comment from a member of our audience, Ed Gallagher. I hope you don't mind I say your name. He said, I believe the XMILE implementation will have a major positive impact on the expansion of system dynamics in life sciences, biomedical, and clinical research. The lack of a cross-platform standard implies a community of provincial vendors. In contrast, XMILE provides much more expansion and flexibility. For example, if a vendor goes out of business or is acquired, etc., XMILE is a great step forward.
Yeah, definitely. I mean, speaking as somebody, I didn't always work at IC Systems, and even for those of you who know me, I used to be at Forio. In the past, I was just a hobbyist, college student, implementing, at the time, open source products based around building interfaces for system dynamics products. And it was always such a bear to be able to try and support more than just a single product. I had to go through and for each product understand all of the highly technical nuances of each of the file formats. And so, like Gary was saying, this specification allows other software tools which may not handle the model portion at all, the actual calculations, to be built around this ecosystem of models and use this huge body of work which the system dynamics community has invested decades into, and actually, re-get that work out, make it more available, make it easier to use. So we've got a great opportunity here, and I think, your statement of rather than looking at this as a bunch of, provincial kingdoms, if we can, unite and actually grow this field, it's going to be better off for everybody.
Thank you, Billy. That appears to be the last question or comment. Steve, if you want to close up for us. You seem to have lost Steve's audio. He had it earlier. So I will close up. Thank you for joining us on this 11th webinar. I hope we can see you again for our last of the 4 webinars that were planned to teach you about XMILE in particular. It should be a very interesting panel discussion with Andy Ford, Brad Stelfox, and Diana Fisher on June 24th at noon. Look forward to seeing you there. Thank you very much.